the last lecture we have discussed about invariance. We have seen the stress invariance, that means invariance of stress tensor I1, I2, I3 and invariance of deviatoric stress tensor J1, J2, J3. In this session, we will try to see some of the important aspects of these invariants and its relationships. Okay, so we are now given a principal stress matrix where sigma is equal to sigma 1, sigma 2, sigma 3. We have seen that the principal stress matrix gives the same meaning and representation as like any other stress tensor in a more simplified form because we have only diagonal elements. We can easily write what is the mean stress, which we know already, it is sigma 1 plus sigma 2 plus sigma 3 by 3. So, we can formulate the mean stress matrix or isotropic stress matrix, which is given as sigma m 0 0 0 sigma m 0 0 0 sigma m. We can always write deviatoric stress matrix because you know the given stress matrix is decomposed into sigma m and sigma d, which can be written as sigma is equal to sigma m plus sigma d. So, one can always write the deviatoric stress matrix, which is given as S1, S2, S3 is equal to sigma is sigma 1, sigma 2, sigma 3 minus sigma m, which is this particular matrix. So, that will give you sigma 1 minus sigma m 0 0 0, sigma 2 minus sigma m 0 and 0 0, sigma 3 minus sigma m. So, the characteristic equation, just like we have done in the previous case, what was the characteristic equation? It is sigma minus lambda I. So, where I is the unit vector. So, here characteristic equation is sigma minus S into I, specifically for deviatoric stress matrix, which is equal to 0. So, one can easily get J1, J2, J3. So, that is what we have done. So, we have I1, I2, I3 and then J1, J2, J3. So, now first we are asked to derive J2, which is the second invariant of deviatoric stress tensor, equal to half of S1 square plus S2 square plus S3 square. So, let us see how to derive this. We know the first invariant J1 is equal to S1 plus S2 plus S3. What is S1? S1 is sigma 1 minus sigma m. S2 is equal to sigma 2 minus sigma m. S3 is equal to sigma 3 minus sigma m. Now, if you take a summation of this, you will get sigma 1 plus sigma 2 plus sigma 3 minus 3 sigma m. Now, sigma m is equal to sigma 1 plus sigma 2 plus sigma 3 by 3. So, if you substitute it here, this will be equal to 0. So, that is why we know the first invariant J1 is equal to S1 plus S2 plus S3, which is equal to 0. If you take the square of J1 square, you can easily write S1 plus S2 plus S3 the whole square, which is equal to 0. So, expand this. So, once you expand this, S1 square plus S2 square plus S3 square plus 2 S1 S2 plus 2 S2 S3 plus 2 S1 S3. So, if you take 2 outside, you can write minus 2. So, if you bring S1, S2, S3 on the other side, you can always write minus 2 into S1, S2 plus S2, S3 plus S3, S1 is equal to S1 square plus S2 square plus S3 square. We also know from the solution of the characteristic equation, just like we had I2, which is sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1, we have J2 is equal to minus S1 S2 plus S2 S3 plus S3 S1. Please compare this and this particular term. So, one can always write this is minus S1 S2 is J2. So, you will get minus 2 J2 is equal to S1 square plus S2 square plus S3 square. So, this can be substituted, 2 comes down. So, it is J2 equal to half of S1 square plus S2 square plus S3 square. So, it is proved. Now, these relationships becomes important towards the end of this lecture, where you may have to use these equations for further proving certain other relationships. So, please make a note of this. The next relationship is to derive J2 is equal to 1 by 6 sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square. You would have noticed by this time that this expression is very important, because this gives us the notion of deviatric stress. So, we will see how to derive this. Let us first see what is S1 minus S2, which is equal to sigma 1 minus sigma m minus sigma 2 minus sigma m. So, this will give us S1 minus S2 is equal to sigma 1 minus sigma 2, S2 minus S3 is sigma 2 minus sigma 3, S3 minus S1 is sigma 3 minus sigma 1. So, if you write S1 minus S2 square plus S2 minus S3 square plus S3 minus S1 square, that will give us 2 into S1 square plus S2 square plus S3 square minus 2 into S1 S2 plus S2 S3 plus S3 S1. What is this S1 square plus S2 square plus S3 square? We have seen in the previous slide, it is nothing but 2 times of J2, and that if you substitute here, it will be 2 into 2 J2 plus S1 S2 plus S2 S3 plus S3 S1 is, this is minus J2. So, substituting it here, you will get 2 into J2. So, this is 4 plus 2, 6 J2. So, 6 J2 is equal to, you can easily write 6 J2 is equal to 1 by 6, that is 6 comes on the other side, S1 minus S2 is nothing but sigma 1 minus sigma 2. So, J2 is equal to 1 by 6 of sigma 1 minus sigma 2 the whole square plus sigma 2 minus sigma 3 the whole square plus sigma 3 minus sigma 1 the whole square. So, this comes from because S1 minus S2 is equal to sigma 1 minus sigma 2. Now, this equation has been used by various failure criterion or yield criterion for defining deviatric stress, and one we have already discussed, that in von Mises yield criteria, the deviatric stress Q is equal to root of 3 J2. So, that is what we have already evolved in the previous lecture. The next relationship is I2 is equal to S1 S2 plus S2 S3 plus S3 S1 plus 3 sigma m square. Now, here it is the relationship between the second invariant of stress tensor with the deviatric stress elements and sigma m square. So, let us see how to do this. We already know S1 S2 plus S2 S3 plus S3 S1. If you substitute that, for S1 is sigma 1 minus sigma m, if you substitute that and expand, you will get sigma 1 sigma 2 minus sigma 1 sigma m minus sigma 2 sigma m plus sigma square m plus sigma 2 sigma 3 minus sigma 2 sigma m minus sigma 3 sigma m plus sigma square m plus sigma 3 sigma 1 minus sigma 3 sigma m minus sigma 1 sigma m plus sigma square m. I request you to please work it out and see for yourself. It is just a very simple equation and rearrangement. If you simplify this, you can get sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1. So, that has been taken in the first bracket minus all these terms are twice sigma 1 sigma m, then you have sigma 1 sigma m. So, it is twice So, similarly sigma 2 sigma m, sigma 2 sigma m, sigma 3 sigma m and sigma 3 sigma m. Yes, so all of them are twice. So, minus 2 sigma m, sigma 1 plus sigma 2 plus sigma 3 plus 3 sigma square m. If you count all these sigma square m 1, 2 and 3. So, that is 3 sigma square m. Now, we know from the characteristic equation of stress tensor, Cauchy stress tensor, I2 is equal to sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1, just like we had J2, which is S1 S2 plus S2 S3 minus of S1 S2, S2 S3 and S3 S1. Same way you have I2 here. Now, here you have this expression. So, I2 can be substituted here. So, this is replaced by I2, and then what is sigma 1 plus sigma 2 plus sigma 3? That can be written in terms of 3 sigma m. So, sigma 1 plus sigma 2 plus sigma 3 is equal to 3 sigma m. So, if you substitute it here, it will become minus 6 sigma m square plus 3 sigma m square. So, you can write now this is minus 3 sigma m square. So, I2 is equal to S1 S2 plus S2 S3 plus S3 S1 plus, so this minus will go on the other side. So, it will become 3 sigma square m. So, this is also equally important. We will consider this equation further. The next relationship is between the third invariant of stress tensor associated with the deviatoric stress elements. So, I3 is equal to S1 S2 S3 plus sigma m S1 S2 plus S2 S3 plus S3 S1 plus sigma cube m. So, we will first start with S1 S2 S3 and we know the expression for this, which is equal to sigma 1 sigma 2. So, we are doing first this 2, sigma 1 sigma 2 minus sigma 1 sigma m minus sigma 2 sigma m plus sigma m square into sigma 3 minus sigma m. So, if you expand, you will get sigma 1 sigma 2 sigma 3 minus sigma 1 sigma 3 sigma m and so on. These I am not reading one by one. So, if you expand this, you will get this. Now, we know I3 is equal to sigma 1 sigma 2 sigma 3. If you notice, all these relationships are more or less identical for I and J invariants. So, one can always replace this by I3 minus, if you rearrange, you can write minus sigma m can be taken out, we get sigma 1 sigma 3 sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 plus, from this you can take sigma m square out. So, sigma m square is taken out, you get sigma 1 plus sigma 2 plus sigma 3 minus sigma m cube. Now, you need to replace it by suitable expression. We know I2 is equal to sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1, which is equal to S1 S2 plus S2 S3 plus S3 S1 plus 3 sigma square m, which we have already derived in the previous slide. So, this also gives sigma m square. Now, the next term sigma m square, sigma 1 plus sigma 2 plus sigma 3 minus sigma m cube can be written as 3 sigma m cube, because this again you can replace it by 3 sigma m. So, 3 sigma m into sigma square m gives 3 sigma m cube minus sigma m cube, that is 2 sigma m cube. So, that will be the relationship. So, then you substitute back all these information, we will get I3 minus sigma m. This can be replaced by S1 S2 plus S2 S3 plus S3 S1 plus 3 sigma m square. I am replacing this by this here plus 2 sigma m cube. So, that will give you I3 minus sigma m into this and minus 3 sigma m cube. So, if you do this operation, it will be minus 3 sigma m cube plus 2 sigma m cube. So, we are very close to the answer now. We have I3, you take all these component on the other side, it will be S1, S2, S3 plus sigma m on the other side, sigma m S1, S2 plus S2, S3 plus S3, S1 plus this will be minus sigma m cube. When you go to the other side, it will become plus sigma m cube. So, it is proved. Now, we have a relationship between the second invariant of deviatoric stress tensor and the first and the second invariant of Cauchy stress tensor. So, let us see how to do this. It is already proved in the previous slide. I2 is equal to S1 S2 plus S2 S3 plus S3 S1 plus 3 sigma square m. So, it is already known to us. We also know I1 is equal to 3 sigma m and sigma square m will be I1 square by 9. So, it is a simple information. What is S1 S2 S2 S3 plus S3 S1? That is nothing but minus J2. And if we substitute for sigma square m, that is I1 square by 9, so we will get this. So, I2, so J2 is equal to, from here, J2 is equal to this particular information, this goes on the other side, J2 is equal to I1 square by 3, this I2 comes on this side minus I2. So, this is known. So, if you take 1 by 3 outside, J2 is equal to 1 by 3 I1 square minus 3 I2, and that is what we need. So, this is one relationship between the both invariants. The next expression and the last one is J3 is equal to 1 by 27 2 I1 cube minus 9 I1 I2 plus 27 I3. Let us see where to start from. This we have already proved. I3 is equal to S1 S2 S3 plus sigma m S1 S2 plus S2 S3 plus S3 S1 plus sigma m cube. We know that J3 is equal to S1 S2 S3. So, that is what has to be brought into picture. So, we can substitute this. So, I3 is equal to J3. So, this one will be J3 minus S1 S2 S2 S3 S3 S1 is minus J2. So, this is minus J2 and sigma m is nothing but I1 by 3. Sigma m is equal to I1 by 3. So, you substitute that I1 by 3 for sigma m and this one, so that will become minus J2 minus I1 J2 by 3 plus, again you can get the cube, there is I1 by cube. So, sigma m cube means I1 cube by 3 cube, that is 27. So, that is what is written here, J2 is equal to 1 by 3 I1 square minus 3 I2. This is already known to us, J2 is equal to 1 by 3rd of I1 square minus 3 I2, just we have proved in the last slide. So, if you substitute this, you have J3 minus I1 by 3, we substitute for J2. J2 is 1 by 3 I1 square minus 3 I2. So, I1 square by 3 minus I2. So, that is what it is, plus I1 cube by 27. So, that will give J3 minus I1 cube by 9 plus I1 I2 by 3 plus I1 cube by 27. So, if you rearrange, J3 is equal to I3 plus we simplify this and this, that will give 2 I1 cube by 27 minus I1 I2 by 3. So, if you take 1 by 27 outside, we can write 2 I1 cube. So, this term first. So, 2 I1 cube minus, if you take 1 by 27 outside, it will become 9 I1 I2 plus here it will be 27 I3. So, that is the required expression. So, what we have done is we have discussed about the relationship between different invariants both for stress invariant and for deviatoric stress invariant. Okay? That is all.